We're being asked to integrate. It looks like u-substitution is probably the way to go, because if we let this be our u, then du will look something like this. It won't be that exactly, but it should look familiar. So let's try it. So we'll set u equal to 17 plus 1 over x, and then du is negative 1 over x squared dx. You might say, how'd you do that so fast? I actually have the derivative of 1 over x memorized. At some point, I got really tired of doing it. To take the derivative of 1 over x, write it like this. Right, there's a 1 here. And then when you take the derivative, you bring the negative 1 down, and you get x, and you subtract 1. And so you end up with this. So eventually, you just memorize it because you get really tired of having to compute it. Okay, so here we have negative 1 over x squared dx. But here we don't have a negative, so let's divide both sides by negative 1 to get rid of it. So we have negative du equals 1 over x squared dx. And now we're in a good place. We're in a really good place because here we have dx over x squared, or 1 over x squared times dx, and that's exactly what we have here. And that's just going to be negative du. So this will be negative, pulling the negative out. And then this piece here, this is our u. So you just have u to the 6th du. And now we can integrate. This is negative u to the 7th, right? You add 1 over 7 plus c, which is equal to, we're dividing by 7. It's the same thing as multiplying by 1/7. So let's write it like this, negative 1/7 times, and then u was 17 plus 1 over x, and it's to the 7th power, right? There's a 7 here, plus c. And that is the final answer.